Hi, Assalamualaikum. Greetings to my lecturers, Madam Hafizawati and Dr. SHAH FENNER. I hope you're doing well. In this recorded video, my group will be presenting regarding ENT334 Component Design Mini Project. Our mini project title is Improvement on Staircase Climbing Trolley. My name is JADDEL, ID number 19112249, and I'll begin our mini project presentation with the introduction section. For decades, various types of wheeled trolleys have existed in the market, but commonly everyone knows the conventional trolley has a basic structure with a pair of wheels at both sides carrying the load. It works well on flat ground, but its usefulness is limited when it becomes necessary to move the carrying load over an irregular surface and climb the stairs. Then, new generation trolley were invented by using the tri-star wheels idea. The setup of the trolley has enabled it to handle the staircase and also to obstacles like holes and bumps on its path. However, there are several issues we found out that meet the trolley limitation, which are space carrying capacity is insufficient, difficulties to handle when pushing up stairs that need a lot of energy to do it, and lastly, regarding condition of the carry item because of unstable when moving the trolley. Next, we move to objective. We have three objectives of our mini project need to be achieved. First, the purpose of this project is to modify the staircase climbing trolley by improving in terms of its functionality and human factors considerations. Secondly, designing projects components by application of CATIA software, which illustrates the orthogonal views of each part in each component and isometric assembly drawing. Third, analysis and structural improvement for carrying load include modification powered by rechargeable motor drive the shaft with the assist of gears, additional spring for the suspension, and applying suitable bearing to smooth the movement.
Assalamualaikum, my name is MOHAMMAD bin MASRI. My metric number is 19110706. So today I would like to talk about the flowchart of our mini project. So firstly, we do some research and study about the stair climbing trolley. Then we sit together to brainstorming the idea. Then we sketch out the idea. Then we do further research about the idea, whether it fits the criteria of our mini projects. Then we prepare the budgets and do the proposal. And if it fail or need addition, we will rethink about the budget, do the proposal. Then if it success, then we design component using CATIA software, make analysis and calculation. Then we do the report writing. Then lastly, we will present about the projects. So now I will talk about the Gantt chart. So this is our Gantt chart. So as you can see, for week 5, we identify group member. Then for week 6, we briefing about the idea. Then for week 7, we choose and select the title of our projects. And for week 8 and week 9, we discussing and preparing the proposal. Then for week 10 until week 13, we do the mini project. We do the design by using CATIA and do some calculations. And for the last week, which is week 14, we do the project presentation.
Each of our group members had designed the parts for the improvement of the staircase climbing trolley, which are the gears, fasteners, welding, and bearings. Pushing a heavy load trolley to the upstairs could be challenging as some people need an extra effort to deal with it. We designed a modification that installed additional power to support the user pushing the trolley to account for this. Installing a DC motor with a rechargeable power supply could support minimizing the struggle to move the heavily loaded trolley. The use of spur gear is essential to ensure the power transfer along the wheels is running efficiently. The suitable gear for this situation need to be designed in high gear to produce a better torque support in moving heavy loads.
So what is fastener? Fastener are used to mechanically join two or more objects together non-permanently. In other words, when you use a fastener to connect two components, you can remove it, and the separate pieces should come apart without suffering any damage. Besides, by using fastener, we can make sure that the component is not loose, so that there was no any damage on our products. So, what is the example of fastener? For example, we have screw, bolt, and nuts. So why these three components called a fastener? These three components called as fastener because they share a common purpose, which is to hold the object together.
Assalamualaikum warahmatullahi wabarakatuh. My name is SYAFIQ, and I will handle for the bearing part. Bearing part is the important role with the driver or any vehicle. For our product is our trolley to provide the first connection between the wheels or for our trolley. And with this friction, it is a friction reduction device placed for something about for our wheels for our stability or so that.
Hello, hi, Assalamualaikum warahmatullahi ta'ala wabarakatuh. So, my name is Muhammad Salman bin Nazaruddin. So, I will continue the presentation with the last improvement of our product. So, the last improvement of our product is spring suspension. So, the suspension spring are the link between the wheels and the trolley body. They connect the wheels to the body elastically and store the energy to absorb and smooth out the shock that are received by the wheels from the rod irregularities and transmit to the body. So the primary task of the spring suspension is to compensate uneven road surfaces and thus provide an assurance of high level of ride comfort. Suspension springs are one of the most critical and important components of vehicles. They affect handling and road holding performance. So if we add the spring suspension, we can improve the efficiency and the performance of the staircase climbing trolley. So here you can see the sketch and the photographic of the spring. So here is the front view, here is the side view, here is the top view, and here is the isometric view. Right? So here is the sketch using the CATIA software. Alright, so next we will continue this next to the next slide. So this is the image of the product before the improvement. So we will move to the next slide. So this is the final project. So here you can see where we add the spring. So we add the spring in between the tires and behind the gear. Alright?
So this is the sketch of gear parts looks like. This is the gear, this is the DC motor, and this is the rechargeable battery attached along with the motor. As you can see here on the graph, this is the front view, the left view, and top view. This 4 bars casing seems kinda lengthy because it will be positioned between wheel shaft and attached beneath the trolley.
So this is the design for the body.
We use 24 of the balls for the ball bearing. We use 24 and 50 degrees, and also the total angle is 345 degrees. And we put the bearing and between of our rim half, and also the in the between of the tires. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about the 20 of the ball bearing we use. And so this is our plan for the bearing. And so we a bit uh, show to our sir about our tire. Our tire is about the concept tri-star tire. Tire is very important for our trolley because it's a main role for this work for uh, the ladder. Yes, if he move for the certain level to another level, it can make it easier. And this is our plan for the our tire.
In the design analysis of gear calculation, because the material we use is C45 mild steel, the factor of safety is 2. Using the maximum normal stress theory and distortion energy theory, we'll get the value of the yield strength. The design of DC motor approximately need to have 100 watt of power, 30 rpm of rotational speed. Using this formula, we will have this value of minimum torque. For the selection of spur gear, need about 44 and 18 teeth to get this low ratio, because high gear is needed for this design. Let's say this value is the torque and the speed. To find the load of this force that will be used in this maximum normal stress theory to find the moment, and use all the values in this torsion formula to find the diameter. This result is the minimum of the shaft diameter to be the selection. Um, our shaft diameter is 20 millimeter, as it is safe to be used.
So this is the calculation for the body, which is beam. So the force is 500 Newton. So by using this equation, we get 56,250 Newton millimeter. Then by using this equation, this is wide and this is height. Then we get 4,160 millimeter cubes. So to find the bending stress, 56,250 Newton millimeter divided by 4,160 millimeter cubes. Then we get 13.66 Newton millimeter square. So the bending stress induced is 13.66 Newton millimeter square, which is less than the bending stress allowed, which is 270 Newton millimeter square. So our design is safe. So let's move to the fastener. So this is the design for the fastener, which is bolts. So let's get straight to the calculation for the fastener. So we use C45 steel. The diameter is 9.31 millimeter. Diameter of M10 bolt is 8 millimeter. So let us check the strength when the initial tension in the bolt when bear is fully tight. So the force is 981 Newton. So to find this, we use this equation. So by using the equation, we get 19.52 Newton millimeter square. So the calculated tensile force is less than the maximum tensile force. So I think our design is safe because the calculated tensile force is less than the maximum tensile force.
And this is the some calculation for our bearing that we perform to make it our bearing is strong enough, so tough and strong enough to carry our tires or to perform our tires for the certain level of the friction, of course, their lifetime, our L10, and we just calculate the allowable rate, and so coefficient FB and FA. So that's it.
So next we will continue with the calculation of the spring. Alright, so our material we use to build our spring is A227 HD steel. So first we will calculate the spring rate. So from table 10.5, the diameter of our spring is 2 millimeter. So the G value will be 78.6 gigapascal. Alright, so the spring rate will be, we will calculate the spring value using this formula. Alright, so here we will get 0.2729 gigapascal millimeter. Alright, so next the length of unloaded spring is 35 millimeter. Alright, so the OD value will be 6 millimeter. The spring diameter is 2 millimeter. Right, so the number of turn of the spring is 9.5 coils, so the active turn will be 9 turns. Right, so hence we can calculate the pitch value of the spring. So to calculate the pitch value of the spring, we have to divide the length of the unloaded spring with the number of active turn. So we will get 3.89 millimeter. So the solid length will be active turn plus 1 and multiply by the diameter of the spring, so we will get 20 millimeter. So the last one, we will calculate the force required to close the spring solid. Alright, so we can calculate using this formula the multiple of the spring rate and the subtraction of the length of the unloaded spring with the solid length. Alright, so we will get 4.0935 gigapascal millimeter square.
Okay, this is our final view for our trolley. This is our scene, and we can see from this sketcher, we just separate for the certain part, important part of our trolley. We consist of the seat tires, about 20 nuts, one shaft, one rim. This is the absorber, the body itself, and also their gear plus the motor. And we have adjustment for the left, right, about right, for the bottom and the top. This is we use the ancient scene, and we just do it by ourselves by learning from the YouTube. Yeah, he is just like that. Thank you. To make it our trolley is clear enough to understand what is a function, where is the part we put our trolley. This we show you the exactly place that we placed them. At first we have the absorber at there for the nut and bolt, bearing in the middle, and in gear and motor we just combine them together. When motor move, they have electric, and the gear also move, and gear will move the shaft and also our tire and the shaft and fastener, of course.
So lastly, as an overall conclusion, the improvement of staircase climbing trolley will be beneficial in workshop or vehicles repairing. So in this mini project, we have learned so much information from do tons of research and collecting information. Alright, so we can also know how to design a project by using CATIA software for assembly part and orthogonal design for our mini project. Alright, so in the end, we came out an idea to design a spring, shaft, bearing, tire, gear, and fastener to improve our selected product. So the improvement in design is useful to manufacture this machine at low cost with capacity to handle the load. Alright, so we have been going through with this idea by completing the component design process, such as finding title to make improvement on the project, making calculation involve orthogonal assembly design using CATIA software, and making evaluation of the project. Right, so in the end, we are so happy with the outcome of our mini project. We hope with all those technique information that we got from this mini project will be very useful to our future and project during our engineering study and work life. Alright, so that's all from our group. Thank you.